Hi, everybody. My name is Jessica Johnson. I want to introduce this fabulous team that we have here. We have Miss Cici.
Hi.
Miss Jazmin.
Hello.
And Miss Claudia.
Hello.
Don't be pushed by your problems. Be led by your dreams instead. And our group is going to talk about algebraic reasoning, graphing, and connections with geometry. So did you guys hear what the acorn tree said when he grew up?
No, what?
No.
Gee, I'm a tree. Here I have a graph that shows an elevator traveling from floor to floor with a length of time that it stops between each floor.
Jessica, is there more that you can tell me by looking at the X and Y axis?
Yes, Cici, I can. By looking at the X and Y axis, the X axis is the length of time the elevator has stopped. Here's the X axis. The Y axis is the height to the next floor level. As the elevator travels along the Y axis, it should remain the same length. The length of time that the elevator stops follows along the X axis, and it may vary. If the elevator is at a standstill for a longer amount of time, then the line along the X axis will be longer. If the elevator stays still for a short amount of time, then the line along the x-axis will be shorter. Now let's talk about functions. So what puts fun into functions? Here's my chart that shows a set of functions following the rules of multiplying by 3 and then adding 8. We are giving 4 inputs, or they're also known as domains, of 0, 1, 2, and 3. And let's just say that we input the number 2. The 2 has to follow the function rules of 3 times 2 equals 6. And then the 6 has to follow the function rule of adding 8. So 6 plus 8 equals 14. I know that all the F's and the G's and the X's and all the parentheses look scary, but once you get to understand functions, they're not all that bad. This is what our graph would look like if we graphed our functions.
Jessica, can you tell me a little more about this graph following the rules of the function?
Yes, I can. Functions have to follow the rules that are given to them. Since the function has to follow the rule of multiplying by 3 and then adding 8 from a given domain, when these variables follow the rules, we get the function of f of x equals 3x, and the output or range would be 0, 3, or 9. 0, 3, 6, or 9. Then the functions need to follow the second rule of adding 8. The domains would have a range of 8, 11, 14, and 17. When f of x of 3x is at, say, number 2, then g, which is the orange line, g of f of x equals fx plus 8 would be 14. This shows a graph with the xy Cartesian coordinates of 3, 1, and 5, 5, plotted on a graph.
Looking at the line segment, can you tell me what kind of slope it has? Vertical, horizontal, slopes upward, to the right, or to the left? How do you know this?
Jazmin, I'm glad you asked. The line segment has a slope that goes upwards and to the right. I know this because of the two given plots of 3, 1 and 5, 5 are in the positive and not in the negative quadrants. We can actually find the slope by placing a right triangle on the line segment and counting the rise over the run, also known as the change in y over the change in x. Counting the rise, there are 4 squares, 1, 2, 3, and 4. And counting the run, there are 2 squares, 1 and 2. Our slope looks like m equals 4 over 2, which is just number 2. This is a graph that shows 3 different parabolas. The way I was able to graph the parabola was by using different variables for my x variable.
What are some of the other variables that were used?
By looking at the chart, there were 5 different variables that were used for the letter x. Some of the variables that were used was from the range of -2 to 2. When the functions were graphed, there are 3 parabola lines. One was in the positive, one was in the middle, and one was in the negatives. Notice how the variable changed with a certain value was put into its place. For instance, when x was -2, the answer was 4. And then when the variable was 1, or x, the answer was 1. From this equation, we can determine the slope and a reciprocal slope for a perpendicular line.
In the given equation of y equals -3/4 x plus 5 with a point of 6, -1, can you tell me what the slope is and how to figure the slope?
Yes, Claudia, let me explain. Looking at the equation, the slope of -3/4, because of the linear equation of y equals mx plus b. We are finding the slope of a perpendicular line, so we need to find the reciprocal slope of 4/3. From here, we can use the point slope formula of y minus y1 equals m times x minus x1. We need to fill in the equation to get y minus -1 equals 4/3 times x minus 6. Then we solve for the variable y. I will use the distributive property and get y plus 1 equals 4/3 minus 8. Since I'm solving for the variable y, when I cross these lines, I have to change this sign when I isolate the y on the left-hand side, and I will get y equals 4/3x minus 8 minus 1, leaving us with an answer of 4/3x minus 9. And here's my perpendicular lines, and we know because we have a 90-degree angle. This is a circle with a tangent line below it.
What is a tangent line? And what if the circle had a tangent line that was parallel? What would it look like?
A tangent line is a line that just touches the outside of a circle. In our problem, we are given the Cartesian coordinates of 0, -1, because we know it is a circle that we know the other Cartesian coordinates of 9, 0, 0, -9, and 9, 0, -9, 0. I will place the tangent line where it just touches the outside of the circle right here. And if we had a parallel one, it would be at the top. And we know that these lines are parallel because they never touch and they are the same distance apart the whole time. Now then, I would like to turn the presentation over to Ms. Cici.
Hi.
Cici, what are the coordinates that are graphed in the equation y equals x squared plus 7?
First, one would make a table for the x and y values. Then start with -2 up to +2, replacing the x values into the x of the equation x squared plus 7. So in other words, we would take -2, square that, and add 7 and get our y output, which would be positive 11. We would do that with each variable in the x-axis, x values to get our y output. Here's a graph showing y equals x squared plus 7 on the graphing table. As we can see, it's 0, 7, the parabola opens up.
The x and y axis in this graph located, and what correlation does this graph demonstrate between the gas in the car?
The x is represented by the amount of distance traveled. The y is represented by the amount of gas in the car. At the beginning of the graph, it demonstrates the amount of gas that the car had before it started traveling. Then the car comes to a stop and fills up. At last, it starts back up and the gas decreases as the car continues to travel. As we can see in this graph, this is our x-axis and this is y-axis, and this is our x-axis. We begin with this amount of gas in our car, traveled, filled up, and began to travel as the gas decreased.
Are the line segments of the given equation with point 5,8 and point 5, -8 horizontal, vertical, slope downwards to the right, slope upwards to the right, or undefined?
First one, we'll use the slope formula, y squared minus y1 divided by x squared minus x2 minus x1. Next one, will label the x and y coordinates in the ordered pairs. And then one would plug the numbers into the equation. So we would do -8 minus 8 divided by 5 minus 5, and that would give us 16. On a graph, this is what it would look like, or -16. So the graph would be undefined.
Is g of x3 equal to 17?
Yes, g of f3 does equal 17. The reason for that is because f of x equals 3x, and g of x equals x plus a. So if we put the equation together, it would give us g equals g of f times 3 times 3. Well, we would multiply and then add 9. So to show you a little example, this is what it would look like. So we do 3 times 3 would give us 9, like right here. And then we would add 8 and then get 17. And if we were to graph this, we can see that on our table, it shows we start with f of x equals 3x and f of x, g of f equals f of x plus 8. And these are our variables used. The orange line would represent f of x plus 8, and the blue line would represent 3x.
What would the line of this equation look like on a graph? Y is equal to negative 3/4 x plus 5 with our point of R at 6, negative 1.
First, one would solve the equation by figuring out which formula will be used. In this case, the formula being used would be the slope-intercept equation. Y minus y1 equals m times x minus x1. Or in other words, rise over the run. To find the slope of the formula by swapping the signs, so negative 3/4 to positive 4/3. Label the coordinates of R and label the 6 x1 and the y negative 1 y1. Then we would put it all in a formula and graph it. And this is what it would look like. So we would put y minus negative 1, because negative 1 is y1, equals 4 divided by 3x minus 6. We would distribute that, and we would get y plus 1 equals 4/3 x minus 8. We're trying to get y by itself, so we subtract 1 from each side and get 4/3 x minus 9. And if we were to graph this, this is what it would look like. And we can do the rise over the run, which we could see 1, 2, 3, 4, and over 2.
Does a tangent line go in the middle at point 0, 0 of the circle?
No, a tangent line is a line that is at the end of a circle. One example would be at the top of the circle and at the bottom of the circle. In this picture, we can see that the tangent lines, one being at the top of the circle and one being at the bottom at 0, 9, 0, 9. And we can also see that they're parallel to each other. Now I would like to turn the presentation over to Ms. Jazmin.
Thank you, Cici.
Jazmin, how do we determine that the two equations of the lines are perpendicular?
Jessica, we are able to determine that they are perpendicular lines by the slopes of the equations. In order for these two equations to be perpendicular, the slopes of the two lines must be opposite reciprocals of each other. As you can see, we have our slope for line A as negative 3/4, and we have our slope for line B as 4/3 x. Those are opposite reciprocals of each other. Next, we can come and look at our graph where our two lines have been graphed, and we can see that these lines are perpendicular, and it creates a perfectly 90-degree angle.
Jazmin, is line C tangent to line A? Why or why not?
Claudia, no, it is not. A tangent line is a line that intercepts a circle at one point only. We see that line C has a point that intersects at 0, negative 9, and 9, 0. And we see that line A has one at 0, negative 9. This one has 2 points. Therefore, no, it is not a tangent line.
Jazmin, how do we determine that this is an undefined slope?
Cici, the first way we can check is through our given points. If we look, we have point R, which is 5, 8, and we have point S, which is 5, -8. And we see that our X value is the same for both coordinate points, which is 5. And this means that we will get a vertical line when we graph it. A vertical line means it runs up and down our axis. The other way that we can tell that these lines are undefined is if we grab our points and we put them into our slope formula. Once we solve, we have -16/0. Because we have a 0 in the denominator, this means that our slope is undefined.
Jasmine, how can we determine if this graph represents a function?
Jessica, we can determine so by performing a vertical line test. This is done by checking the graph to see if any vertical line drawn would intersect our curve, right here, more than once. We'll go ahead and perform that. Drawing a vertical line there, we see it only crosses it at one point. We'll repeat. We'll check at a different spot. Once again, our line only touches one spot, and so on. Therefore, the graph does represent a function.
Jasmine, from this graph, can you explain how to find the slope?
Claudia, first, you would have to determine at least 2 points on this line. I will pick 3, 1, and I will pick 5, 5. Since we have our points, now we can use our point slope formula to determine our slope. We will plug our values in to our formula, and then our slope will be determined at 2. We can also check it on our graph by performing our rise over run method. This is done by the change y over x. We will go up 4 and over 2.
Jasmine, how do we determine if the coordinate points 2, -4 is a product of the function y equals x squared?
Cici, we could do this by determining it 2 different ways. So we know that 2 would be our x value because it's represented first in our coordinate points. And we see that we can go ahead and put our 2 into our function of y is equal to x squared. When we do so, we get y is equal to 4. And therefore, yes, our point 2, 4 is a product of the function of y is equal to x squared. Second, we can go to our graph that we have created based off of our table, and we can go here and try to find this point on our parabola. So we will look for the point 2, 4, 2, 4. So yes, once again, it is a product of the function. Now we will turn this over to Miss Claudia.
Here we have the graph that shows the function of a man's gas tank as he fills his gas on his drive across the country. The amount of gas is represented by the y-axis and the distance traveled is represented by the x-axis.
Claudia, what do you mean by the x and y-axis?
That is a great question, Jasmine. I'm glad I can clear it up for you. An axis is a fixed line of measurement. In this lesson, we refer to the lines or axis on a graph. Within a graph, there are 2 axes or lines of measurement. These 2 lines are referred to as the x-axis and the y-axis. The y-axis, commonly referred to as the vertical axis, measures the graph vertically, while the x-axis measures the graph horizontally. This is from a question asking us to find the answers to a series of equations once set variables have been plugged in order to form a graph.
Claudia, what is a variable?
A variable is a piece of an equation that may change or that has yet to be solved. In most cases, and in this equation, the variable is the letter x. Since it is a variable, it is subject to change, which we can see here with the numbers 0, 1, 2, and 3. Rather than having a set equation, there is a variable to make room for a set of answers instead of just one answer. See, for this function right here, we have the answers 0, 3, 6, and 9 because of our variables 0, 1, 2, and 3.
So what is a function and how is it related to what we know about variables?
A function is just an equation or a relationship that uses at least one variable. Most variables, again, are written as the letter x, but any letter can be used. With a function, each input, or the variable that is written in, only produces one output. So we see here the variable 1 produces the output 3. The input 3 produces the output 9. They cannot produce more than one output. We can also stack functions. See here we have the function of f and the function of g, but the function of g includes the output of f, so the functions have kind of been combined. With the variable of 2, the function of f produces the number 6, but then you plug the number 6 in for the variable of the function g, and you get the number 14. These functions also produce a y value. That is the answer that we're looking for. And since the variable was an x, then we can use these numbers to plot a line on a graph because we have x and y values. This problem here asks to take a set of points and determine and describe the slope relationship of these 2 points.
What exactly is a slope and how does one find it?
Excellent question. Slope is the measurement of how steep a line is. Within an equation, slope is normally represented by the letter m. Determining the slope can actually be done a number of ways. The most common method is referred to as rise over run. So you would determine how much the line rises and then how much it runs. So you could go right here, 1, 2, 3, 4, and then the run would be 1, 2. It is normally written as a fraction with the change in the y value as the numerator and the change in the x value as the denominator. So change in y over change in x. Slopes can also slope upward, downward, or even be a vertical line.
You mentioned vertical lines. If a line is vertical, does it have a slope?
That is an excellent question and can be kind of confusing. A vertical line does in fact have a slope, but it is not a traditional slope. Traditionally, as I said before, slope is defined as rise over run. But with a vertical line, there is no change in x, meaning there is no run. Since there is no run, meaning the x value is always the same, which we see here with the 0.58 and 5 negative 8, both having 5 graphed over here is a vertical line. Since the x value is always the same, then it is undefined because there is no run, as I said before. Vertical lines, no matter their length, have what is known as an undefined slope.
Can you determine the direction of a line just by looking at 2 points from the line?
Actually, you can, Cici. That is a fantastic question. You can actually determine some parts of a slope without even performing a mathematical equation or plotting points. The question is, do they have anything in common? As you can see here, these 2 points have an x value in common. They both have 5, which we can know, since there's no change in x, that it's going to be a vertical line. So we can know just by looking at these 2 points that they're going to be a vertical line. The same goes with the y value. You see here, this line has the same y value for point T and the same y value for point U, which forms a horizontal line because there is no change in the rise. Right? Everyone, thank you for listening, and we hope we cleared up some stuff for you.
Bye.
Bye.